Hi everybody, welcome to the part 2 of concept of load balancers. My name is Ashish and in the previous video we have covered some of the basic concepts upon load balancers. So what exactly did we cover? We covered what are load balancers and why did it came into existence, what problem did it solve, and how do we configure them. So that is what we covered. Apart from the core concept of load balancers, we happen to understand that whenever load balancers come into discussion, we happen to talk about L4 load balancers and L7 load balancers. So we understood what are L4 load balancers and what are L7 load balancers. So this is what we covered. Apart from that, we also understood three important load balancers, which is very widely used in the market. So first one was Nginx load balancers. Second one was HA proxy load balancers. And third one was AWS load balancers. Now today in the second part, we are going to actually implement what we have, learned in the last video. So here what we are going to do, we are going to do a practical implementation of load balancers. So what exactly are we going to do? So I'll quickly guide you through the steps, what exactly we are going to do. So we are going to step one, we are going to create a fast API application. So in my recent videos, if you have gone through, we have almost created the fast API application in the similar way. So I'm not going to create from scratch. I'm going to guide you through the steps like how we have created this fast API application. Then second, step two goes is like we'll be dockerizing that application, dockerizing the fast API application, and we'll be accessing it on the local host, accessing through localhost. So once this is done, then in step 2 we'll be spinning three more containers. So in step 2 we'll be spinning two more fast API containers and accessing them through localhost, but of course via different ports. So accessing them via local host. Now in step 3, we are going to install and configure step 3. We are going to configure Nginx load balancer and see how this Nginx distribute loads across all the three servers whenever there is an incoming request. In step 4, we are going to uh, see the concept of sticky sessions. Sticky session simply says if a request user is coming from a particular IP, it has to be routed to that particular server. Even if it gets log out and if the user resends the request, it has to be routed to the same server. So that is what sticky session means. And in step 5, we are going to do a load test. Do a load test wherein we'll be sending almost 1,000 requests to those servers at a time, and then we'll be seeing that how these particular requests are routed using the load balancers, right? So let us begin. So first step, so we'll go to the first step. So first step is like we'll be creating a fast API application. So let us quickly go through the terminal. So what are the steps of creating a fast API application? So if I have to guide you through the steps of creating a API application, so we'll be writing a main.py file, and inside that main.py file we'll be writing the fast API code. Apart from that one, we'll also create a requirement.txt file to say that fast API and unicorn servers are supposed to be installed. And in the third steps, what we are going to do, we are going to create a Docker file and create an image out of it. So these three things I've already done, but let me show you where exactly it is. So currently we are at MacBook at the desktop. So let us go to no. I think let me see where are we exactly now. Let us go to PWD. Okay, we are at user Ashish. Let's go to desktop. Then there is a directory called Newton's lab. Oh, okay, and so that has been Discover Newton now. Discover Newton, and underneath that there is YT projects, And inside YT projects, let us see what is there. There is a FastAPI application. So let us see, go inside the FastAPI application. Just a second. Okay, so let us go inside the Fast API application. But instead of going to, okay, let's go inside Fast API application. So we have got a lot of files over here. So first we'll see what is inside the this file. So first we'll go to fast API application and main.py. So this is the fast API application file. So what this particular file exactly does. So if we see in the first two line we have written import OS and from fast API import fast API. So basically fast API used to build API server, and the OS over here is used to read environment variables, which is very important, right? Now in the second line of the code it is a app is equals to fast API. So this is basically, this creates the backend application object, and every route which gets down here is attached to this object, right? And getting down to this particular server name. So this server name, the section which is written over here, os.gentenv. So it basically reads the environment variable named server name. If that variable if that variable doesn't exist, it returns to the default server. So this is what we have defined over here. And here this is what gets executed whenever we are visiting the root I mean forward slash or the root URL. So this particular home function gets triggered, and here we can see hello from server name. So this is our main.py file, and apart from that one we also happen to create a requirement.txt. So let us see what is the requirement.txt that we have created. So here, as I said, fast API and UVCon is the requirement that we have created, and we'll also see the Docker file what is being done over here. So here it is from Python, that we will be using a base image of Python over here, and inside that container we'll create a directory called as app, then copy all the required files to that particular location, and then we'll be installing all the dependencies that we have declared in the requirement.txt file, that is the fast API and UVCon. So once that is done, we'll expose this particular application to port 8000, and then once the application is running, so it will run the command this UVCon app.main.app, and the host is 0.0.0 and the port is 8000, right? So we have to use the command to build the image, docker build hyphen t, and then the name of the image, that is fast API LB. But to save time, I have already built the image followed by a dot. Dot says that current directory. So let us see docker images. So I have already built an image out of it. Perfect. So now what I'll do, I'll just spin one of the spin one of the instance. So here it is docker. Then the command is run hyphen by d, that is detached most hyphen p. P states about the port. So the port is going to be first is 8001. 8001 is on the host, and the container is running on port 8000 as we have declared over here. If you see, this is what I have declared. So port, and again there is an environment variable, because every time we are, so um, if you see into this particular file over here, so here it is saying hello from server name. So server name is the environment variable that will be passing on here. So what do we write here? Environment variable is server underscore name, and equals to, what is the value? Let's say server 1 or server 1, right? This is what we have said, and hyphen hyphen name of the container, let us put the name as container 01, and followed by image. What image we are using? We are using fast API dash LB is what we are using. Okay, I hope the command is correct. Let's see. Okay, perfect. So we have our container that is running. Let us see the process status. So container is still running, and let's see if we can access it over here. So what we'll put, localhost, and what is the port? 8001. Yes, so we have got the output here, that is hello from server 1. So what we'll do, we'll quickly spin up two more instances of this very application. So here what we have to do, we have to use a different name, that is container 2, and it is supposed to be hello from server 2, so that we understand what server the request has been diverted to. And here it is 8002 is what we'll be exposing. So this is again two containers are running. So if we now go to 2, so we could see hello from server 2. Server 2 is also running. Now let us spin one more instance over here. So let us go to container 03, and then there is server 3, and then there is port 8003, right? Okay. So let us spin one more instance of it. Okay. Now let us see if the third instance is already running or not. Perfect. So are all the three instances are running. If we change the port, we could see, a response from various servers. So step one is done. So step one, what we saw over here is like create a fast API application, dockerize the fast API application and accessing it using localhost. That is done. Even step two is done. That is two more fast API containers. That is also done. Now what we are going to do, we are going to configure our um, Nginx, right? So let us go into cd hyphen user hyphen okay, what is inside the user? Let me see. Um, cd hyphen user standalone. Okay, let me see the path. So it is user local. Let us go to this location first. So this is the default location wherein the Nginx stores the file. So first we have to check the do we have Nginx installed or not. So what we are going to do, Nginx hyphen v. Okay, so we could see the version over here. So Nginx is certainly installed. Now we'll go to that location cd, and this is the location. So let us see what file is there. So we have to create a fastapi.conf file, and what does this file have? So if we quickly check what does this file have over here, so we'll see cat fastapi.conf, right? So here if we see fastapi.conf here, so here we could see two sections. This is upstream fast API server, and which is also catering localhost 8001, 8002 and 8002. So this is basically a group of backend servers. So think of it as like all the fast API servers that we have spinned up right now. Nginx will load balance across, right? So any request that Nginx is receiving, it will divert it to these particular three instances or three particular machines that we have created, the fast API applications. Right now, in the second section, it says that Nginx listens on port 80, and using a proxy pass, it says that whatever HTTP request is coming, it has to go to fast API server. So where is this fast API server? This is over here, right? So Nginx is taking the request, listening on port 80, and then it is routing to 8001, 8002, or 8003, right? So let us see what is the status of Nginx now. Brew services start Engine X. Wait, before starting Engine X, let us see if this file is passing all the checks. Okay, the test is successful. Now what we are going to do, we are going to brew services start Engine X, right? Let us see what happens now. Okay, so Nginx is successfully started. Now we don't have to use the port because Nginx is will be using the directly local host over here, and it will be routing the request to different locations. So yes, it is working. Hello from server 1 is here now. If you refresh, let's see, it is routed to server 2, and then again server 3, 1, 2, 3. So what Nginx is doing? Nginx is doing a round robin over here. So if we just understand what we have done, so we have created a so we have configure Nginx over here. So Nginx is listening on port 80. Whenever is request coming down here, so it is going to container 1, container 2, and container 3. So every time we refresh, first it is routing to container 1, then it is going to container 2, and then it is going to container 3. So parallelly, it is distributing the load. So whenever a request is coming, first it is going to 1, then 2, then 3. So this is a beautiful example of round robin algorithm, which is used by Nginx over here. Now coming back to the second part, let's say what we have to do, we have to use sticky sessions. So sticky session, as I said, so if a user has been routed to a particular server, let's say server 2, so using sticky session, if this particular connection has been disrupted, the next time the user log in, it will always log into server 2. So let us do that as well. So what we'll do, we will do a little modifications in our fast API server file, fastapi.conf, and what we are going to do, we are going to add a statement over here which says it to be IP hash, right? So what we are going to do, we are going to put up a IP hash over here. So let us go IP underscore hash. So what this IP hash does, so IP hash makes Nginx use client IP address to decide which backend server it should go. It is not taking a decision independently, but it is using the client's IP address now. So again, we have to save it, we have to do a Y, and then we need to restart it. So it will be brew restart, no, brew services restart Nginx. Let's see. Perfect. So this has been done. Now let's see. We are currently logged into server number 3. So if I refresh, it is always going to server number 2. Why not server number 3? Server number 3 was the last request, but here, when we have made a fresh request, it was the turn of server 2, and now we can see that if we, put our request, Nginx is, looking at server 2 over here, and it is routing our request to server 2 itself. So we can also try in incognito mode. So let us see local host only. And if we see again, it is going to server 2. So you must be asking a question that Ashish, it is okay to route the particular request to server 2 on the default window. But when we are going incognito, it should not be routing to server 2. It should be routing to some other location. No, the problem here is, as I said, that IP hash is basically using the client's IP address. So although we are accessing the request on this incognito mode, it does not change the client's IP address. The client's IP address 127.0.0.1 is going to be same whether we access it in the default browser or in the incognito browsers, right? So yes, so that is the concept of sticky session over here. And now what we are going to do, we are going to again make the modification. We have to remove the sticky session so that we can make some more modifications over here. So let us delete this. Okay, perfect. Now let us save it. We have to make a Y. We have to restart the Nginx service. Perfect. So now what we are going to do, we are going to do a load test over here. So what is the load test that we are going to do? So we are going to make parallel 1,000 requests to our servers. So what exactly are we going to do? So we are going to, first step is we are going to use AB benchmark tool. So AB benchmark tool. So this comes with HTTPD or Apache server. So we really do not need to install Apache server, but again we have to install Apache server. Why? Because we have to use the tool AB. So AB is Apache benchmark, right? And what command are we going to use? We are going to use AB Apache benchmark hyphen n. Hyphen n here is like send a total of 1,000 requests over here, and hyphen c said that send 10 requests at the same time, concurrency, right? 100 request, and what is the location? We have to send the location at http localhost, right? So this is what we are going to do. So here, 1,000 requests, total 1,000 requests will be sent to those servers, and at a single time, 100 requests will be sent. So this is what we how we are going to check the load testing, that under the when there is huge traffic, how does Nginx behaves over here. So let us check that do we have Apache installed over here in our system. So httpd -v is here. So okay, Apache is over here. Now we will now what we are going to do, we are quickly going to run the this first. Let us check that now the sticky session works, or how does it behave. So if I see server 1, server 2, server 3, so it is routing to all the three servers parallelly equally. Now what we are going to do, we are going to use Apache final by hyphen n send 1,000 requests, and hyphen c send at least 100 requests at the same time. To what location? To http localhost. Local host, right? Because it is difficult for us to refresh 1,000 times and check like how it is getting routed. So okay, benchmarking, be patient, test about it after 10 seconds, invalid arguments. Okay, this could be some of the other spacing issues, but let me see. I must have this command handy with me. So if we go down and let's check this one. Okay, benchmarking loss, be patient. Okay, let us check the logs, whether this has been done or not. Docker PS. and then we'll go Docker logs 52. Let's go for 52. So yes, so it has been receiving the request over here. Now let us see for any other containers. Let us see about 0, 9. See, it is getting the request. And let us go for the third container. What was the third container named as 31? So 31 is also here. So it is also getting the request. So do you see that how beautifully and intelligently Nginx is routing the request across the different servers, right? So here, what all we have covered in this particular session? So we have uh, three servers is what we have spinned up, and then we have used Nginx, and then we have routed the traffic across all the three servers, right? And post that, we have understood the concept of sticky sessions. How does it work? Using the IP of the the source system from where the request is coming, using IP hash. And fourth, we have done the load testing, right? So this is the practical implementation of what all we have studied about load balancers in the previous video. I hope you like the video, and you can run this similar project in your system. Maybe you must be using a Windows system, so all the commands are really very handy. And you can get it online on Google, everywhere, and you can just perform this real-time implementation. So I'm very much hopeful that you have liked the first video, that is the concept building part of the load balancer, and second, the practical implementation of load balancer using Nginx. So thank you for watching the video, and see you in the upcoming videos.